Integration. Well, we just spent a long chapter on that. But we do know a lot of the integration rules. So this problem doesn't present any problems to us. If it's to the fifth power, I raise that by 1 and I divide by that new number. So it's x to the 6th over 6. Keep that 9 out front, and now I have x to the 4th over 4. Over here, I have 2x to the 1st. So that becomes x squared over 2. Of course, the 2's will divide out. That's all right. What is this plain old negative 6? Isn't that equivalent to x to the 0 power? So when I integrate negative 6, it's like saying negative 6 x to the 1st over 1. But then we hit that problem. Isn't this just x to the negative 1? And if you were to integrate x to the negative 1, you raise the power by 1, x to the 0, and then divide by 0, which is not allowed. We'll skip that for a moment. And then finally, this one was x to the negative 2. Raising that 1, it's going to be x to the negative 1st over negative 1. Everything works out except for that middle term. What are we to do? If only we had a really good rule to deal with this situation. Ladies and gentlemen, we learned earlier that the area under the reciprocal function is equal to the natural log. We also know that the derivative of the natural log is 1 over x. How could this possibly help us figure out some of these integrals? Now, when you're doing examples of these, you're looking for something that's a logarithm. You see something that might be x to the negative 1st, but it's surrounded by its friends or other stuff. This is a composition of functions, and this is where you need U substitution. When you're doing these problems, if you notice the denominator is 1 degree higher than the numerator, there's a good chance it will be logarithms. So you need to write out what U is going to be and what du is going to be. U will almost always be the entire denominator, and then you can take the derivative. Solve for dx, and once you've solved for dx, plug everything back into the equations. Once I've substituted in, now these problems are going to go a lot easier. I'm going to take all the numbers and move them out in front of the integral sign, and then we'll see that it's just exactly the same as my logarithmic integral rule. See that, folks? We've cleared up. The x's divide out in the second example. The numbers I just moved out front. And now you can write it out as a natural log of u. You see, that's what those are. Those are the natural log of u. Please remember, though, when you finish up u substitution, do not plug u in here, because we were told much earlier that u was going to be equal to 7x plus 4. Or in the second example, u was going to be equal to 5x squared plus 1. Those are two of the basic examples, and we'll be looking at reviewing some integral rules and also looking at long division just one more time as a way of simplifying and rewriting problems. Hope you enjoyed that.